Okay, so let's continue with two examples. Then you will understand the SPRT procedure well with these examples. Actually, it's not a difficult procedure, but let's see some other examples. Okay, so let's say we have a normally distributed random variable where sigma square is known, and we have a simple hypothesis case, mu equal mu 0 versus mu equals mu1. And what is the direction here for the tests? Let's see. Okay, so let's say mu 0 is greater than mu1 case. Okay, for a given alpha and beta, generate SPRT for alpha equals, let's say, 0.05 and beta equals 0.10 again. Okay, these are approximately achieved, so let's derive that. So to be able to do that, we need the simple likelihood ratio. So for regular likelihood, as for normal, is 2 pi sigma square over n over 2 e to the minus summation xi minus mu square over 2 sigma square, where the range of mu is this one, the range of x is this one. Then we can find the simple likelihood ratio by getting the ratio of the likelihood under the null and under the alternative. Okay, after some calculations, we will get, let's see, summation xi squares goes, so this should be 2 sigma square, 2x bar, mu 0 minus mu 1 minus mu 0 square minus mu 1 square. Okay, as you can see, this is a function of n and x bar, which is a function of n and sample random variable x bar. Okay, so we know what is k0. K0 is always defined by alpha a, 1 minus beta a, and this is approximately for our given alpha and beta, this one, or approximately 0.056, and k1 is calculated by this formula, 9.5. Okay, so then we can define our rejection region. Reject case, reject as soon as L less than or equal to K0, which is already calculated. Okay, and except case also known, except as soon as L sub n, let's say K1, which is 9.5, and continue if our simple likelihood ratio, 0.056, L sub n, and 9.5. Okay, so if this is the case, we will continue taking samples. Then rejection case. Okay, so if L n less than or equal to K0, this means that, again, using natural logarithm makes calculations easier. So we will have n over 2 sigma square, 2x bar, mu 0 minus mu 1 minus mu 0 square minus mu 1 square, and then k sub 0. So when mu 0 greater than mu 1, this is positive. so we don't have to change the position. Then this means that we have x bar less than or equal to sigma squared k0 divided by n times mu0 minus mu1 here, plus we have mu0 plus mu1 over 2, which is our c sub 0 numerically calculated. Okay, so we have to replace k0, mu0, mu1 given from the sample from the hypothesis, sigma squared already known, and for different n values we can calculate this. Okay, then for the acceptance region, all you have to do is replace ln greater than k1. So this means that basically we will have kx bar greater than or equal to sigma squared, replace k0 by k1. Okay, so same thing, only change the direction, replace k0, this is k0, k0 by k1, and mu0 minus mu1 plus mu0 plus mu1 over 2. Let's say this is our c1. Okay, and then continue taking samples if our values, our x bar is between c0 and c1. Okay. Okay, so if mu1 is greater than mu0, then you will see that our rejection case will be x bar greater than or equal to c0, except case will be x bar less than or equal to c1, and continue case will be c1, x bar, and c0. Okay, so all directions will be different. So as you can see, the procedure is very easy to use. Let's focus on another example. Let's say we have a Poisson random variable. Okay, and let's say we want to test theta equals 0.02 versus theta equals 0.07, and here alpha is given as 0.02 and beta given as 0.10, and we want to find Sprt. Okay, so this is our question, and first of all we need to find the likelihood function under the null hypothesis and under the alternative hypothesis. So what we will get at the end, so we have e to the minus n 0.02 and also 0.02 to summation xi over multiplication of xi factorials e to the minus n 0.07, 0.07 to the summation xi, multiplication of these multiplications cancels out, and we have e to the n 0.05 and the ratio 2/7 to summation xi. So this is our likelihood ratio. Then we have to calculate k0 and k1. So k0 approximately, alpha a over 1 minus beta a, 0.02 and 1 minus 0.90, so 2/9, and k1 approximately this value, okay, 0.8 98 over 0.98 over 0.10. Okay, is it 0.20? How did I write? Okay, 2 over, this is 10, sorry. Okay, so this will be 0.98. Okay, so it will be very high. Actually, it should be 0.20, but that's okay. So we find this. Then what we have here is okay, so the rejection. So reject H0 as soon as L sub n less than or equal to K sub 0. We already calculated as 2 over 9, right? Then again take the ln of both sides. Okay, so what we have 5 2 plus 2 over 7 and oops, I don't. Okay, sorry about that. Okay, then summation xi ln what we have. Okay, so 2 over 7, which is a negative quantity, less than or equal to ln k0. Okay, then we have summation xi greater than or equal to ln k0 minus n times 0.05 over ln 2 over 7. Okay, so let's say this is our c sub 0. Okay, and when we calculate this c sub 0 is calculated as 1.197 plus 0.04 n. Okay, then the accept region, accept H0 as soon as R greater than or equal to K1. We already calculated K1. Since my calculations, okay, so let me correct it actually. So let's write it 0.20. Okay, and so this is now correct. I have to correct this one also. 88. Okay, so then I can give the correct calculated value. Then we will have summation xi. All you have to do, change the direction and replace k0 by k1. Okay, so you don't have to do any other thing. Okay, so this is C1, and when we calculate, we will get minus 1.66 plus 0.04, and okay. As you can guess from the numbers, basically C1 will be in the upper lower bound and C0 will be in the upper bound for the continue case. So continue if K0 and K1, but from here, you know, tests should be based on some test statistic. Are C1 summation xi and C0 minus 1.66 plus 0.04 and summation xi and 1.17 plus 0.04 and okay, so that's the end. Okay, then see you guys on Wednesday at 11 a.m. If you have any questions, we can discuss that. Bye.